Welcome to my class. Today I'm going to show you the example 3 using the Gauss-Seidel method. This is the problem of example 3. Given the initial guesses where x1 equal to 1, x2 equal to 0 and x3 equal to 1. The iteration will stop when the epsilon A is less than the stoppage error, or known as epsilon s, which is 0.5%. So, in the first step, we need to rewrite all the equations and solve for its unknowns, which are x1, x2, and x3. In step 2, we need to build a table to show the iteration, the estimated roots of x1, x2, and x3, also the epsilon A for each x. Let's see how do we carry out the calculation of x1. We use initial guesses of x2 and x3 given in the questions to determine the new value of x1, where we get the answer, which is 21. Next, for the root x2, we use the new value of x1, but we still use the old value or the initial guess of x3 because there is no new value of x3 being determined yet. As for the estimation of root x3, we can use all the new values. This means that during the calculation of x values, we always use the most recent values. Forget about all the old values. As you can see, the iteration process is similar with what we have learned in Chapter 2 about the closed and open methods in solving the roots of equation. We will continue the iteration until we meet the epsilon A is less than 0.5%. However, the solutions since cannot be obtained even after 6 iterations. The relative errors are not decreasing at any significant rate. What is wrong? Even though we've done the calculation correctly, the result is not converging to the correct answer. Can we fix that? A system with a diagonally dominant coefficient matrix will always converge. So, now let us check whether the matrix is diagonally dominant. In fact, it is not. So, what can we do now is apply the partial pivoting to swap the row 1 with row 3. Yes, now the system is diagonally dominant. We repeat the step of Gauss-Seidel method. Finally, after 7 iterations, the iteration stops when all epsilon A is less than epsilon s. The solution obtained is also very close to the exact answers. Thank you. That's all for today's sharing. I hope you can understand.